Hello students, in this video I will explain the convergence of the series by comparison test. So we take the two series and we have to find the convergence of both the series. So we suppose the first series is in this form. So we write un is equal to 2n minus 1 upon n into n plus 1 and n plus 2. We write this series in compact form where the numerator term is denoted by 2n minus 1 and denominator is denoted by n plus 1 and n plus 2. So we take the common in first term in numerator. This is n 2 minus 1 by n, and this is n 1 plus 1 by n and 1 plus 2 by n, and this is n cube because we take the common from n plus 1 and n plus 2. So this is n cube. So again we simplify it and we obtain 2 upon 1 minus n, and in denominator term this is 1 plus 1 by n and this is 1 plus 2 by n. We choose another series Vn is equal to 1 by n square, and by comparison test we divide un by Vn and take the limit n tending to infinity. So un is nothing but 2 minus 1 by n, and this is n square 1 plus 1 by n, and this is 1 plus 2 by n, and this is n square by 1. So n square and n square is cancelled out and we take the limit n tending to infinity. So this is nothing but 2, which is finite and non-zero. So the convergency and divergency of un is only depends on the nature of Vn. Since Vn is equal to 1 by n square, so using t-test, summation of 1 by np is convergent if p is greater than to 1 and divergent if p is less than or equal to 1. Here p is equal to 2. So Vn is convergent hence un is also convergent. Next we have to solve the second series and we write in a similar manner un is equal to n plus 1 upon n to the power p. 2, 3, 4 and 5. So the numerator term is written in the form of n plus 1, whereas the denominator term is written into form of n to the power p. So take the common of n in numerator. So this is 1 plus 1 by n and this is n to the power p. So this is nothing but 1 plus 1 by n upon n to the power p minus. So this is Vn, and we take Vn is equal to 1 upon np minus 1. So by comparison test divide un by Vn and taking the limit n tending to infinity. So this is 1 plus 1 by n upon n to the power p minus 1 into n to the power p minus 1 upon 1. So n to the power p minus 1 and n to the power p minus 1 is cancelled out, and if we take the limit n tending to infinity, so this is nothing but 1, which is finite and non-zero. So the convergency and divergency of un is only depends upon Vn. So Vn is nothing but 1 upon np minus 1. So using p test, which is given in this slide, summation 1 by np, n is equal to 1 to infinity, is convergent if p is greater than to 1 and divergent if p is less than or equal to 1. So Vn is convergent if p minus 1 is greater than to 1. This implies that p is greater than to 2, and Vn is divergent if p minus 1 is less than or equal to 1, meaning thereby p is less than or equal to. So on the basis of the nature of the Vn, we have to conclude that Un is convergent if p is greater than to 2, and Un is divergent if p is less than or equal to. I hope it is clear for you. Thank you.